Please welcome Renee James.
Good morning. They're right. I was listening to everyone say how excited they were to see real people out here, and it turns out I am too. Welcome, and thank you to OCP for having me talk today. Welcome to all the people who are online. I understand there's a lot of people online as well. I'm excited to see people back here again. I am going to talk about a couple things. First, I'm going to introduce you to Ampere if you don't know who we are, and then talk about what I think is happening in our industry. It's an exciting time to be in this business. It's almost like the renaissance of computing. I can't believe I saw so many big chips come out. I was so excited about that, semiconductors everywhere. And then talk about the contributions that Ampere is going to be making to OCP and the importance of what we do here at OCP and why a young company like ours would be making the kinds of contributions you'll hear about this morning. So for those of you that don't know who we are, we're a 4-year-old company that I started to build what we think comes next in semiconductors and specifically in compute. So we had a point of view that there was something that would come after what we had been working on and I had been working on for my whole career, which was an important, huge growth of computing in the PC and the PC client server era, but that the data center had been really progressing over the 10 years. We've been doing OCP for 10 years, and most of us that have been in this industry know something that's repetitive and true, that every 10 years, you're kind of into a cycle where you think, oh gosh, we've been doing data centers for so long, we are so far into this thing, but what we're not at is the knee of the curve in growth. So let me share some data with you. In the next 4 years, data centers will double, and what we think is the middle or maybe kind of into the knee of it is the beginning. And if we continue on the path that we're on, it'll take twice as much power. And we just heard the last speaker talk about how we need to be environmentally friendly. We've heard all about the climate summits. We can't continue using technology that was developed for the last wave of computing for the next wave of computing. Not only that, we would need 60% more space to put it into because it's not dense enough. This is why I founded the company, was to build and to work with the industry and the community to build what I think we need to do for the next wave. Because we're not at the end, and we're not even in the middle. We're at the beginning of the massive growth phase that's super important to all of us. If we were so lucky as to build the entire growth phase out with a modern approach, that's what we kind of like to think about at Ampere, the modern approach to semiconductor compute design, we would need less power, less space, and we would achieve the goals that all of the companies that we work for, work with, and our partners need to accomplish in ESG. Look at what we've done for 10 years. Congratulations to all of you that have been making these contributions. The community matters. It's what spurs innovation. It's what enables the industry to grow in new directions. It's what shares that R&D uplift with so many other, and it is what allows small companies to thrive. But guess what we haven't done in 10 years? Actually, it's been 43. We have not had a fundamentally new compute architecture in 43 years. Jeff, my chief product officer, is going to come out and talk about what we're contributing to OCP. He wasn't born when x86 was designed. So some of you might say, okay, Renee, let's get real. 64-bit extensions, how long ago was that? Do any of you know? I'll take anything from anyone out there. 22 years, okay? I don't need to say it's legacy. I'm a legacy. I spent my whole career working on it. I love it. It's a great architecture for what it was designed for. It is not for the cloud. And shoehorning it into the cloud has been very productive, but I don't think gets us where we want to go. So what we need to do is to move in a new direction with more power efficiency, continuing to deliver top-tier performance, and features that are made for cloud-native software and services. And we know that change comes when the software model shifts, right? The software model shifted from mainframe and mini compute to Windows client server. And a whole wave of compute was deployed, 30 years of it. A lot of great companies built on it. The software shifted. It shifted. We need the hardware to shift with it. And that's really what Ampere computing is about. 3 things that you need to do. You got to deliver predictable performance. You need it. It has to be consistent because the users require it and the workloads require it. Linear core scaling. I worked a long time on threading. So I feel that when I stand here and tell you that linear core performance and throughput is a really important thing, that's kind of like, oh my gosh, why did I waste all that time doing threading? But the software is different, and it requires different things, and that's what we have to keep in mind. Look at all that growth. We just need to switch to a new compute paradigm. And the power per core, while the performance is going up, has to go down, and we're not going to get all of that from process technology. Some of it has to come from design, and not just core design, but also the packaging design and the platform itself. So, Ampere, 4 years old, 2 products in the market. I'm going to show you my silicon because everyone else has, so I want to be a joiner. This is our 128-core, 7-nanometer product, okay? It's 2021 and it's shipping on 7 nanometer, 55 billion transistors. And you can look it up online. It's been measured by third parties, top-tier performance with anything that we're making with an architecture that I know and love. Imagine what we're going to do with our 5 nanometer product that we'll be sampling in Q1. Because you already heard what you're going to get out of 5 nanometer from TSMC, 2x improvements, 25% more performance. We already got 128. We don't have to wait till 2024. So if you are interested in learning more about this, of course, you can come to our booth. It's all going to be there. It's running workloads live. All the platforms, the products are all there for you to see. But in addition to that, we have several of our customers who've come public. A lot of them have not, who have instances running today, like Oracle, like Tencent, like Ali, and Microsoft's already announced that they're working with Ultra and Ultramax as well. So more to come on that as you hear from us as we talk about what's happening with our 5 nanometer generation. And it won't just be performance. Of course, you have to have top-tier performance to matter. But as we look forward, the innovation has to come at the feature level. It has to be coming from specific workload enhancements for the things we care about, like AI, like how we deal with security, how we deal with memory, and other things like that. So, open compute. You guys have been working on really important things that matter. We started this company with the intent of working with the community to move the industry forward into the future. I have been a big proponent of open and community projects my whole career, starting with the Linux Foundation and on from there. It is something that we take for granted now that we didn't do 2 decades ago. The contributions, the hard work of all of you in this audience and that are online, they matter. And sometimes we forget to say thank you. Thank you for deciding to be part of the community. Thank you for making contributions that move this industry forward. Thank you for keeping something like OCP going in the face of a pandemic and in the face of lots of other priorities and things to do that don't include contributing back. So with that, what I'd like to do is take a few minutes and talk about what Ampere is going to be contributing to OCP. So I'd like to introduce Jeff Wittick, our Chief Product Officer, to help me do that. Hi, Jeff.
Hey, Renee. Thanks. Well, you talked about all of the contributions that we're going to be making to OCP.
And now you're going to talk about them for real.
I'm going to talk about them for real. Yeah. So first off, I am pleased to announce that the Ampere Mount Jade platform is now OCP accepted. This is a platform that we've been working with WeWin to develop. It's now available in the OCP Marketplace from WeWin. We've also released the design files and the specifications for this server. That way, everyone in this community can take advantage of the innovations that we've made and then build upon that, and also be able to adopt it with some of our key ODM partners as well. Now, this is the first ARC64 server that's available through OCP. So talking about that, that transition from legacy to the next generation and to modern compute, this is a key piece of that.
Yeah, as I said, I mean, a lot of the activity has to come from not just doing new cores, and I'm going to talk about that as I wrap up about our own core and some of the innovations we're making, but also we know at the platform level there's a lot of work to be done. So I think this is a big moment. And again, you can imagine as a very young company for us to decide to just participate and contribute. So I'm excited about that, and we're hoping that people will be equally excited and start using it.
Yeah, for sure. And like you mentioned, yes. So you mentioned the fact that it's more than just the CPU. So this server supports the 80-core Ampere Ultra. It supports the 128-core.
The one that's in my pocket.
Yep, Ampere
It
Ultra
looks
Max.
as big as an FPGA, but it's not one because it's compute.
Yes.
Yeah.
Yes. So we got 128 cores packed in there. In this server, that means that we can support 256 cores across the server. So a lot of compute for those cloud-native workloads. And it's not also just about the CPU and the physical hardware. It's also about the firmware and the software. That's a key piece of putting this all together.
That's right.
That's right. So another key piece here is we've contributed back the open source firmware for this platform into OCP so that end users and ODMs can directly innovate and deploy really, really easily. If we look forward to the future, there's a lot of stuff that we also have planned in the future. The DCSCM module, given its modularity and its cross-platform compatibility, this is going to make it really easy for end users, ODMs, to innovate in the space around security and manageability. And our next generation reference platforms include DCSCM in the design. So right off the bat, you'll be able to start innovating on our next gen CPUs.
I hear a little applause.
Hear a little clap out there. Yeah, someone's excited.
Thank you.
And when it comes to the firmware and the software, it's not just the firmware for this platform. We've also at Ampere been building out open source firmware, working with people like AMI. We've worked with Linux Boot. We've worked with OpenBMC, Tiano Core, and with the OCP community. And we've been able to directly enable our ODMs with firmware. And then we've also contributed back key pieces of our firmware, like our EDK2 code or our OpenBMC code. And that's a really, really important part of enabling this broader community. Renee mentioned some of the big customers we have, the big hyperscalers.
That's right.
Well, it's important that we really spread this out across the ecosystem and make it possible for everyone to get their hands on this technology and innovate on it.
Yeah, I think one of the things that we know from past experience is that no one company affects a transition on a platform. It takes literally a community and the entire ecosystem. So as excited as I am about what Jeff and our engineering team and everyone has delivered thus far, I think the most important next step is to get all of you excited about it. And this is what this contribution is about. The software part being one of the most important pieces because without it, it's a little bit hard to get going. Mm-hmm. So thank you, Jeff.
Yes, absolutely. Thanks, Renee. And thanks, everybody.
Yeah. So as you can see, we have a very ambitious goal for all of you, and we are intending to deliver on our promise. That's why I insisted that we become a member of OCP at the platinum level and that we work hard to make this magnitude of contribution despite being a relatively new company. Because I know that in order for us to realize the growth that's in front of us, the really exciting part of what we're all doing here is the fact that you need new compute and you need a new approach. We need density. We need predictable performance. So I want to just wrap up by talking a little bit about our future in the next decade of computing. There is one more thing. There's always one more thing. And that is not only have we not innovated in compute for the last decade, and I'm being gracious, we have not been on cloud time. The compute engine for the data center, for the cloud-native data center, has not been on time. Cloud time is annual cadence. It's not every 4 years or 5. It's bringing innovation and invention to all of you and to our customers and to our users every single year. So what you'll see from us is new products, sometimes new platforms, always new features on an annual cadence. That's cloud time. Ampere was born on the cloud, for the cloud, to speak to the needs of what cloud native needs. So what you're going to see from us on an annual cadence is a series of products. The first two are already out. The next one is coming shortly, 5 nanometer, another 5 nanometer. Very exciting products. You can imagine that because you're all engineers and it's just math, right? You can figure out what's happening with 5 nanometer and figure out what we could do with that. But for all of you that don't build CPUs for a living, but build every other thing that we need, memory, network, what have you, graphics, we all need to get on the same program about design and about the future of design for the environment that we're going to be living in. And that means power efficiency, in addition to density and the ability to deliver compute in a more compressed framework, if you will, in a footprint that our globe can, the world can absorb. So with that, I want to invite all of you to come visit us, get to know us, use our things that we're contributing to OCP, and get excited about what's in front of us. Because we have a really, really bright future. That's why everybody else is finally excited about silicon. And I want to thank the OCP team again for letting our young company come and speak to you today. Thank you.